Hi, hello. Today I want to talk a little bit about this project that I have talked about before. This cilium pwru project. So this project is to trace the packet in the Linux kernel, and yeah. So pwru has a BPF program that is in this kprobe pwru.c file. So basically, it used the BPF kernel probe feature to trace the SKB packet in the kernel. So here is the BPF hook point kprobe. So you can see here it used kprobe hook point, and here is the BPF program with the context as the function parameter PT register, the function parameter passing through function through register. So we have a kprobe SKP1, kprobe SKP2. What this BPF program does is for the SKP1, it takes the first argument parameter function parameter argument is the SKB. So we can see here, this is the first parameter cast to SKB. And so the second kprobe SKB2 is the second argument is SKB, the packet SKB packet buffer. So the third, this is a third argument as the SKB buffer. Again, the fourth argument as the SKB buffer, and the fifth argument as the SKB buffer. So basically, what PWR does is it will attach 5 BPF program to all the SKB functions in the kernel, yeah, so it will trace every SKB functions. It will trace every kernel functions with SKB as an argument from as the first argument to the fifth argument. But the problem with this is it will take, when you start the pwru program, it will start to load the BPF program and attach to the kprobe hook point for each kernel functions with SKB as argument, function argument. So there is like over thousands of kernel functions with SKB as argument. So it will take maybe more than 30 seconds to attach those to those functions. So it takes time to start up the pwru. Not very ideal in a production system. And and by the way, the pwru project used the cilium ebpf Golang library to load the ebpf program and attach to the kernel functions. So it used this cilium ebpf library, right? So again, this is the cilium ebpf library as a user space BPF program loader to load ebpf program. So there is a new feature in this library in version 0.9.2 release. This new library release version support a new API. It's called the link.kprobe.multi API. So what this new feature does is it can blazingly fast bulk kprobe attachment to kernel 5.18 or newer version. It means you can do a batch attachment to kernel functions through kprobe hook. So it will speed up the load. It will speed up the attachment process. So when you have like over 1,000 kernel functions you want your ebpf attached to, it will speed up the attachment process. So maybe usually before it takes 30 seconds, but for this feature it will take less than 1 second. And so I can show you a demo first to show you the difference. So here is the so here is my hack on the pwru project to use the new cilium ebpf multi kprobe attachment feature. And so on this version, on this machine, I'm running kernel 5.19, which in this newer kernel, it has the kernel multi kprobe feature enabled. So for example, I'm going to run this pwru program here. And so you can see here, it's immediately attached to all the kernel functions. And say here is 18, 0318 and 0319. So it's about like 1 second. So we can test, send a pin request to this machine. So we can see the pwru show all the kernel functions that has the SKP buffer as the argument, and show you the functions that has the ICMP processed. And yeah, so it's very fast. And also, if I press Ctrl+C to stop the attachment, it also like less than 1 second to detach the BPF program from the kernel functions. And it is blatantly fast, right? So now let's see another machine which actually running kernel 5.18 version, but so it should support the kernel multi-kernel kprobe feature, but it will not. But you will see. I'll run this same pwru program. You can see here it has error here. Failed to attach multi kprobes. Operation not supported. Right. So you can see here this one it takes 0445, 0456. So it's about like 11, right? 11 seconds to attach to all the functions. So here is the number of kernel functions. It's like 11,071 kernel functions, and it takes 11 seconds. So it is way slower than the multi-kprobe. And so, by the way, since I'm running kernel version 5.18, which should have the kernel multi-kprobe supported, but why it is still failed? The reason is that the reason is so here again, if I type Control-C to detach, it also like take long to detach the BPF program from the kernel functions. So both attach and detach is slow. Yeah, so back to this why operation not supported. It is because I will show you this, my hack PR request. So in this pwru, I have a draft PR request. So this is a hack this is a hack PR because the code is not well designed, and but it works. So so I'll explain why the operation is not supported. It's because I think it's in the last statement here. So again, if I use the strace to trace the system call, we can see here when the system call to call this operation to create the BPF link, and it's got an error not supported, operation not supported. So then the reason is because for multi-kprobe, you need to enable kernel config fprobe, because the multi-kprobe feature is based on this config ftrace probe kernel config. Yeah, so you needed to know. I think normally the distribution, the Linux OS distribution usually will have this turned on, but because my machine runs, I compile my own kernel, so I forgot to enable this. So I got a operation not supported on my kernel 5.18 version. Yeah, so that's the thing. And also, so again, to this draft PR, also to support this multi-kprobe, one thing I learned, another thing I learned is that I got this error when I try my hack PR. So it says invalid argument, missing kernel symbol or program attached tab is not this. So what's the problem? And so the maintainer BRB find the answer and give me the clue, because maybe I'm not using the trace kprobe multi in the section here. Yeah, so I forgot to modify the BPF program kprobe pwrc ru.c file and change the section to kprobe multi. So that's the problem. That's the error. I got this invalid argument and the wrong attached tab. And another minor detail I also learned is that you can actually look at the BPF system called load operation. So here is when you attach a BPF program, first it has to be loaded into the kernel and through the BPF program node operation. And in the node operation, if you use strace to strace the BPF loader program, and you will see something like this. So it will give you the program name, what your BPF program name is in the strace, and it will also show this expected attach type BPF C group let ingress. So here you can also tell the difference because when the program is loaded, it will tell you what expected attach type it expect, right? So here it expect BPF C group inet ingress instead of this BPF trace kprobe.multi. So from the BPF node system call, you can tell maybe your BPF program has the wrong attach type. So yeah, so here is another clue. For example, do I have the correct load? Let's see. Yeah, so here say I have the expected this is not it. Yeah. So that's the second thing I learned. So again, the first thing is make sure your OS distribution has this config fprop enabled. Usually it is not a problem. The distribution should have this enabled on kernel version 5.18. The second thing is make sure your BPF attach type is set to this BPF trace kprobe.multi, which is just in the section you use kprobe.multi, right? And so the third thing I learned is this. So I have the first two things figured out, but I still failed with partial attachment. So there's some function attached successfully, but not all of them. So I have this this error message. Couldn't find one or more symbols. File does not exist. Failed to attach multi-kprobe. Couldn't find one or more symbols. File does not exist. So for this error, what I figured out is after I read the kernel code, so in the kernel code, kernel trace bpf trace.c, when we try to, it will like in this function, bpf kprobe multi-link attach, that's the actual attach function. It will first find all the addresses, instruction IP addresses for all the symbols, for all the kernel function symbols. So it will basically translate each function, kernel function symbol name to a kernel address. If for some reason, if all the functions you give, if all the function symbol names you give to the symbol, and the kernel and this function cannot find the address for the symbols, it will log error, and the error is it returns the error search. So, and yeah. So, but I have, yeah. So, and it's also, here's the problem. Also, the maintainer BRB give me the clue that we may need to check if all the functions actually exist in this available filter functions, because underneath the kernel kprobe feature use the ftrace subsystem. So ftrace has this available filter functions provided from the kernel, and so only functions that exist in this available filter functions can be attached. Yeah, so in my hack, I needed to make sure all the functions I give to pwru also exist in this list of functions. And yeah, you can do a simple cat here, and there are a lot of functions, all the ftraceable functions in this file. Yeah, so that's the third thing I learned, right? And actually, there is a fourth thing. Maybe we can just look at this code more in the code. In the kernel code. Okay, look up the symbols. Ftrace lookup symbols. So in these symbols here, you can in this ftrace lookup symbols function here, you can see. So it basically uses this function, k all symbols, to look up each symbols we give to the kernel and to resolve the addresses. So here we have the number of the kernel functions and the sorted kernel functions symbols. So what this function return is that it will return every error search when this when the number of the functions we give to kernel does not equal to the number of symbols functions that are resolved with addresses. So when this is not equal, this function return every search. So what this means is there is this, if I give there is this thing, I actually send it to the kernel mailing list. Okay, let's see bpf mailing list. Okay, multi-kprobe. So yeah, so I send a question to the bpf mailing list, and to give an example here, so I have this simple ebpf program to attach to ebpf program. So I use the kprobe multi feature. But when I give the symbols to the kernel, here is the symbols. I use duplicate symbols. So I wanted to trace. I wanted the BPF program attached to this v print k functions, kernel functions, but I give it two, like it is same functions. It is duplicated functions, and then the kernel will return because let's look at the code here. So here I have two duplicated kernel functions. So the number is 2. It is the 2 kernel functions. But when this function try to resolve the v print k, it can only find one addresses function address for this v print k because it is same function, right? But I have number 2 instead this only resolve one address. So the font is only 1, but the number is 2. So I get every search, right? So I get the same error search, and then so in this PR, but I get the same error search, but I get this error. So regardless, I will get this error. Couldn't find one or more symbols, but it doesn't give you clue. Maybe you could provide the duplicate symbols to the kernel, and it will have this same error message. So that's a little minor detail I also learned, and so when I use the cilium ebpf library. So yeah. If you want to use cilium ebpf to do multi-kernel kprobe attachment, maybe you need to be aware of these 4 things and to save your time. So by the way, this is just my hack. And actually the maintainer BRB, he had a more well-designed draft PR. And so this is his draft PR. It will have it will work the same, but with better code design. Yeah. So yeah, that's what I wanted to talk about today, and what I learned about the kernel multi kprobe. Thank you for watching. Bye.